those, I would say when you wrote them down, anyway, on the answer sheet, check which ones you got right, which ones you got wrong, and then fix it. Like I said, I'm not selecting this, but just so you can kind of see how well you did on your own. So I'll go through the answers first and then go back over any work. So number 1 should have been negative 11. Number 2 was negative 8. Three was 11x minus 4.
I got 25x minus 14.
Okay, we'll go over that.
Just go over.
Sure.
It's because the way you did it differently than I did.
Okay.
What did you do?
Hold on 1 second. Number 4 was b equals 4. And number 5 was x equals 12. Yes, Matt. What was number 1 again? Negative 11. Okay, so for number 1, when you evaluate, you're putting values in for variables and simplifying. So 9 in for x, negative 2 in for y, but make sure you're using parentheses. Make sure you're putting that exponent on the outside of said parentheses. Negative 2 squared is positive 4. Multiply negative 5 and 4 to get negative 20. And then subtract to get negative 11. For number 2, however you remember order of operations, PEMDAS, GEMDAS, GEMS, GERMS, whatever. Some sort of grouping parentheses needs to come first. Do 5 plus 3 to get 8. Do your exponents, you can do them both at the same time, do one at a time, either or. But you need to get this to be 64 and this to be 8. And then any multiplication or division, so multiply 4 and 8 to get 32. From here, you could subtract and then add, or add and subtract. I subtracted first to get negative 40. Plus 32 gives us negative 8. Yeah. This. You can grade yourself. In past years, I have collected this. I'm not doing that this year. Mm-hmm. Okay, so for number 3, when you combine like terms, you're doing whatever it says, not the inverse, not the opposite. So 18x minus 7, exactly what it says to get that 11x. And 5 minus 9 to get that negative 4.
It's so confusing about everything. Think about all this.
So I would say if it's on the same side, don't change the operation. If you're moving it from one side to the other side of the equals, then change the operation. But in this case, there is no equals. There's nothing to move. So same side, same operation. For number 4, you needed to distribute. The negative 7 times the negative 3 should have become a positive 21. Combine those like terms, doing whatever it says, negative 4 plus 21 to get that positive 17. Subtract 14 to the other side to start getting b by itself. And then divide by 17 to get. For number 5, there were a couple different ways you could have went about that. But the way I did this was get rid of 8 first by subtracting. And then you have a fraction or you're dividing. The only way to get rid of division is to undo it, to multiply. And you would end up with a positive 12. Questions on any of those?
Yeah, I think you know
which part did I do? So this first part I just rewrote it. Yeah. I'm trying to get rid of everything that's connected to x, so I gotta get rid of this negative 4 and the 8. I got rid of the 8 first by doing the opposite. So then, I'm going to rewrite this. When I brought this down, I had this equals -3. Just that part. To get rid of this -4, we would need to multiply. So when I multiply this, I get -4x over -4. And those become just 1x. But what I do to one side, I have to do to the other. This is how I got -4.
Guys, real quick on the one where the variable is in the numerator, like this x over 5 and y over 2, that scares people. It scares me. It gets multiplied. So think in terms of reciprocal. You see 1 over 2, what's reciprocal is 2 over 1. What's that going to get you? It's going to get you 2 over 2, which equals 1. That's what you're trying to get when you're multiplying, or when you have a variable in the numerator. You've got to somehow make it 1x. The only way you can do that is by multiplying it by reciprocal. So you get 5x, 5 times x, and 1 times 5, so the 5 is going to go out. This one, y over -2. So up here, you're going with what? -2 in the numerator, and then -2 divided by -2 equals 1. So you get what you want. You get y by itself. So those are just think in terms of reciprocal. 1/2 is going to be 2 over 1. Anytime you see in the denominator, you're just multiplying it times its reciprocal. So that's what happened up there. It looks scary because it's the -4 up there is over 1. That's what I always put it over 1. That way it tells me it's like the fraction with the variable in the numerator. It's numerator denominator, so I just create my own numerator denominator. So as opposed to just, if I just put like this, 2 times x over 2, it's like, well, I don't know that that's 2 over 1. That makes it easier.
Thank you.
So today we are starting new notes in our new unit on linear functions. A lot of this stuff should look familiar to you, might be review, but we're still going to go through it. The next unit is also linear functions, but like a different part of it. We basically broke this into 2. As always, the calendar is tentative. Dates can change. As you look at it, you'll see things like due this day if we finish. So that really depends on how far we get, if we finish, things like that. So right now, all of the dates in Canvas on the calendar are accurate, but that can change depending on if we need to finish a day later or something like that. Really quickly, just because we'll get this announcement later, and I just want to make sure we're all on the same page. So I graded most of your tests. I'll be putting those into the grade book, and then later today there'll be an announcement that comes from Canvas about like retakes. So I don't believe I mentioned this, and I just want to make sure we're all on the same page. So if you had like a science or maybe a previous math class that did benchmarks or quarter tests, we're kind of going to be doing that, but it's going to be a little different. How it's the same, so the retake won't happen right away. You will have a chance to retake. It'll just be towards the end of the quarter. How it's different is you won't be retaking like everything from Unit 1 and everything from Unit 2 if you don't need to. So it'll be like normal retakes, retake what you need to, but it'll be all at once at the end. So when or if you need to retake, you'll come after school, we'll go through your tests, you'll do test corrections, do some additional practice. That could be something I give you, Delta Math, something like that. I believe I said make sure you don't have any missing Khan Academy assignments. And then once all of that is done, later, you'll be able to do that retake whenever we do that.
So the Khan Academy is always full credit quarters. You do them at any time.
Say that one more.
So for the Khan Academy, are you going to do like any time of the quarter?
Yes, I would recommend doing them before the test.
Yeah.
But yes, you can always go back and redo them and things like that.
I need this.
Any other questions about retakes? Oh yeah. Okay. Yes.
Can you tell me what email I use for
Not at this moment, but if you ask me later, yes. Okay. I have like 50 million copies of this, and I don't know what classes I handed it out to or did not. I feel like I keep skipping this class. I'm just gonna ask. If your parents were here back to school night, I gave them this. It's really just the syllabus, and it has the class codes attached to it. If they weren't there and I didn't pass it out in class, and you want this, you can raise your hand and I'll bring it to you. Otherwise, all these are going to go in. So the syllabus is on Canvas, so you do have access to it. And it's really basic. It just talks about the class. Alrighty. Let us start these notes. And actually, I meant to do one other thing.
cut them down? Make sure you ain't.
I'm gonna pretend I did. Yes. I'm gonna save this first and then I'll write it. When doing intercepts, our X-Intercept algebraically is when y equals 0. Graphically is where it touches or crosses the x-axis. When finding the Y-intercept is the opposite. So when x is 0 and where it touches or crosses the y-axis. So I'm going to now write that, but just know that's what I said. Or what it says. X-intercept, graphically. So, X-intercept where it touches or crosses the x-axis, algebraically where y is 0. Y-intercept is the opposite. So if we're looking for a y-intercept, x is 0. If we're looking for an x-intercept, y is 0. X-intercepts have different names. you might see these instead of X-intercepts. But just know that these words are interchangeable. Solutions, roots, rows, and then of course X-intercepts. Yes, but one is where y equals 0, the other one is where x equals 0. Yes.
When Jordan is back, can I use it? Well, he took my notes. I can scan them. Actually, can I just wait till he comes back? Sure.
Okay. So from a graph, you're just looking at where does it cross the x-axis, where does it cross the y-axis. So for number 1, it might be easier if you look at your own paper than trying to look at my graph. So for number 1, where does that line cross the x-axis? And again, it might be easier to look at your own paper than trying to look at mine. Oh, sorry, you guys couldn't have said it out loud, but yeah, at 2. So list that as an ordered pair, 2, 0. X is at 2, the y is 0. Positive 3, negative 3. Or our y-intercept would be at 0, negative 3. So. Jump to number 2. What are the x-intercepts there? Negative 4 is one of them, and positive 2 is the other. So you could list them both as ordered pairs. Or you can list them. So that would be x equals, anytime you list numbers, they're in curly brackets. Let's pretend mine look like curly brackets.
What's the value of y on the x-intercept? Always. What's the value of y on the x-intercept? 0. What's the value of y on the x-intercept?
Gosh. Go back. Come back. Come back. Why are you waiting for a phone? Why did you grab it?
Because you don't need it. You can't pay attention to class.
Give her back her phone. The y-intercept for number 2? 0.
Oh.
Yep.
What's the value of x on the y-intercept?
0.
Never forget those two. Y-intercept, x is 0.
We're going to do one more of these together, then I'll let you try the others. Number 6. What are the x-intercepts? Number 6, yep. Negative 5 is one of them. 0, 0, and 3. Yep. So you can list them all out. Negative 5, 0, 0, 0, 3, 0, or least to greatest, like this. And then our y-intercept is at 0. Sometimes those are the same. Do we have any questions on how to find intercepts from a graph? I'm going to give you the next 5 minutes. It may not even take that long to try the other 3, and then we'll come back and we'll talk about those.
Or,
I mean, it's really your own fault.
what do you mean? I went to the bathroom when I came back and they were there. I just said hi. when I came out the bathroom, you already came out. You were waiting for me, huh?
For number 3, your x-intercepts were -5 and 5. So remember, if you have multiple, you either need to list them in curly brackets or list them as ordered pairs. Not a combination of both. And this one had 2 y-intercepts as well at the same places. For number 4, you had 2 x-intercepts at -3 and 3. And then 1 y-intercept at -3. And then for 5, you had 2 x-intercepts at -1 and 5. And 1 y-intercept at -2.
Wait, what the crazy brackets you have for?
If you want to list out multiple intercepts. Questions on those? The biggest thing with these is remembering where your 0 goes when you put your ordered pair. Because if you put the 0 in the wrong place, you're putting the wrong intercept.
On the X-intercept, what's the Y value?
She ruined me.
X-intercept, what's the Y value?
0.
Zero.
0.
You should roll out of bed in the morning saying, X and Y is, you should say that before you go to sleep.
Alright, so we're going to do a few of these if I can. Some of these will look like this format. This in front, the f of x, that's the same thing as y, so if that confuses you, rewrite it, take the f of x out, put y. When we're looking for x-intercepts, we're going to put 0 in for y. When we're looking for y-intercepts, we're going to put 0 in for x. So for number 1, if that f of x confuses you, what I could do is rewrite this as y. I'm looking for my x-intercept, so I'm going to put 0 in for y. And solve for x. So all the solving methods we were just using in the last unit aren't going away.
Where'd you get 0?
So we're looking for our x-intercept, so we have to put 0 in there. Kind of, right now it came out of nowhere, but since I'm trying to get my x-intercept, I have to put 0 in there.
You're not serious.
So solve for x. Add 8 to both sides. And divide both sides by 4. Yes. Yes. So our x-intercept would be at 2, 0.
I have a question for number 3.
Okay, you can ask it.
So for the negative x, we wanted to add the x to the other side, and then the x y equals +7.
So
Minus y.
that one, there's an invisible 1
Yeah, I
right
see
there.
that. That's why I said like the plus x to the other side.
You could do that, and then still do this method. We're gonna do some here in a second where X and Y are on the same side, so that would work. You would still kind of solve it the same way, but we'll see that here in a second. So just kind of going back to your question, the 0 in our answer is that same 0. Okay. For our Y-intercept, I'm going to rewrite this problem, but now I need my X to be 0 since I'm looking for a Y-intercept.
What's the value of X for the Y-intercept? 0.
So it's going to be just y equals negative 8, yeah. Because this becomes 0, and this just becomes negative 8. I meant to write these so they don't look like 4s. If it's in this format, coefficient or number in front of x, and then a number by itself that doesn't have the x, whatever this number is always going to be your y-intercept. So you don't really need to solve for it if it's in that format. You can just say, or you can look right there, that's the y-intercept, and write it down.
We already solved we already solved for X and Y.
Yes, but not, well, that's technically what we did, we just did one thing at a time, so yes and no, you wouldn't actually solve it at the same time.
Yeah.
We're gonna jump down to number 4, Josh. And do the same thing. We're looking for an X-intercept, so I'm going to put this, or change this to 0. Instead of rewriting it, you still can do that. I'm just going to put this as 0. Because I know that y and f of x are the same thing. Usually when you have y equals an equation, or y equals something, it's an equation. F of x equals something is usually a function, but they mean the same thing. If you cross multiply here, you would need to get rid of the 6 first. But cross multiplying with that would kind of be the same as like multiplying by the 6. So we'll do that in a second. So get rid of the 6 by adding. And then we could just multiply this by the reciprocal, which in this case would be the same thing as cross multiplying, because you would still be multiplying 6 and 3. But here, 2/3 times 3 over 2 would become 6 over 6, which is just 1. 3/2 times 6 would be 3 times 6 over 2 times 1.
So you had me to add a 6 and then you lost.
Oh.
Yeah, you kind of lost.
Okay. Where and where?
After plus 6.
Yeah, after the plus 6.
Okay. So let's
Because
back
you
up.
put the 2/3, you put the 3 over 2 on the other side of the 6.
That's smart.
So from here, if I wanted to get rid of that fraction, kind of like what Mr. Murphy was talking about before, multiply it by the reciprocal so you get 1. So we need to multiply it by 3 over 2.
Yeah.
Does that make sense?
Wait. Let me write down. Really not the equation, do you? Okay.
But what we do to one side, we have to do to the other. When I multiply 2/3 by 3/2, I get 6/6, which is 1. So these cancel each other out. And then multiply this together. And divide.
So you wouldn't.
Wait, so you wouldn't multiply the bottom?
The 2 and the 1?
Because Josh,
Yeah,
put,
2 times 1 is 2.
put a 1 under the 6. Josh.
Right.
So you wouldn't multiply 2 and 6?
No.
No, you multiply both.
There's a 1 underneath the 6, you would multiply the 2 and the 1. All numbers have 1s underneath them, so look at this, all of these numbers up here, on this number line,
No.
all of them have an imaginary 1 underneath, you just don't see it.
But it'll still be end up being 6-1, even if you multiply it with 6.
No. You're multiplying across. So you're multiplying 3 and 6, and 2 and 1.
Oh, that was.
Josh, does this equal this for $1? Does that equal that?
Yeah.
Negative 3 over
No,
negative 3 over 1.
because
Yes.
someone else
Does this equal that?
The negative 2 and negative 3, yeah.
Number 1, though, this is negative 3 over 1. Are you sure?
Then no.
Huh?
No.
You better be sure it is.
Oh, so right.
Yeah, don't second guess yourself. So I
So I'm
see,
right on there too.
yeah, I see what your confusion was. So usually we cross multiply if there's an equal sign. Is that an equal sign in between this? So we're just multiplying directly across.
Okay.
So we get 18 and 2. This 2 goes with the 1 underneath the 6, not with the 6. You still look confused.
I just don't understand.
Understand which part?
The whole thing.
It's literally just like
And then how'd you get
18 divided by 2. What's our y-intercept
0.
for this one? The y is 0 for our x, but negative 6 is our y-intercept.
So when it asks us for that, when it asks us like this, is the x going to be the y?
It would probably just give you the problem and say find the intercepts. So you need to go from here to here. Is that what you're talking about? Oh, like if you know what that is. Yeah, so if you know that this, like if you could do that in your head, you don't need to simplify that, you can just put fine. I was just putting it out just in case. Other questions on that? You need to do one more of these. 1, 2, 3. So we were gonna do 6. We're gonna do 6. Yeah.
I love what we're doing before this thing.
This is easier. Yeah. But you won't always get it from a graph. Sometimes you'll get it from the equation. So for number 6, if I'm looking for the x-intercept, y needs to be 0. So I went ahead and I put f of x equals 0, or I changed that to a 0. Now I need to solve for x.
Okay, so you already started from this.
Negative 1. Oh, like this step? Yeah, sorry. So we have that fraction, take its reciprocal, multiply it on both sides. -4 times -5 is +20. 2 times 1 is 2. 20 over 2 is 10. And what would the y-intercept be? Do we have questions about either of those data? The y-intercept. So if it's in this format, you can look at this number because it doesn't have an x. So if I put 0 in for x here, this middle part is going to become 0, and I'm just going to be left with 4. That's why we can just look at this part and see that that's the y-intercept. Yes.
Where'd you get 10 and -4?
+4. This 4 came from this.
Okay.
This 10 came from -5 times -4, which is +20 over 2. For sure.
So how do you split -5?
Okay, so let's do this. -2. What are these two things doing to each other? Multiplying. So in a normal sense, I would need to divide, but that doesn't look nice, that fraction over that fraction. So when you are dividing by fractions, what really happens, like if you were to put this in your calculator takes this number and multiplies it by the reciprocal. And that's what it's doing every time you divide by a fraction. So when we jump to multiplying by -5/2, we're really doing all of this, but skipping that first part of dividing. There were questions on that one? That was good.
So people see me again this school year after school.
That's fine. Mr. Norfolk, did you want
On a function of x kind of sounds. I just think of functions like if you're making candy bars, everybody eats candy bars. Everybody else.
I do.
Function means just something you put in, something else comes out the other end. You put a function, you put some number in, put a 2 in. This function goes through the, you get the card bar. Put a 3 in this function here, it goes through the works and you get a Snickers bar. So a function is just, it's called y. It just means you're putting a number in the robot to make your candy bar, putting it in the machine to come out with something else. That's all it is. So AFDA just means a function, you put the number in, you're going to get something out. I like to think in terms of candy bars because that's what I eat. Something goes in, something else comes out. That's a function. But we put y in that function of that. Or it says y.
I'm going to show you a couple of these here later. Jump to that last page. The one that looks like this. Because we're going to do some of these algebraically, but I want to show you that it's kind of the same thing. It just looks different. So, Preston, this is kind of what you were referring to when you were talking about moving the x. It'll end up looking like this. We're going to do a couple of these together. The first time we do this, I'm going to do it fully to show you exactly what we're putting in, how we're solving it. And then the next time, we're going to simplify it a little bit. So for this first one, if I'm looking for the X-intercept, I'm putting 0 in for y, just like before, so that part has not changed. that's supposed to be a 0. Let's pretend it is. We're still going to solve for x. So this middle term would become a 0. Which means, really, all I have is 8x equals 24. And I can solve and divide to get 3. Right. So 3, 0.
Those are like basic math.
No.
Josh, you're wrong.
How? How is like basic math?
It's-
Josh, just put that. So you see where it says 3y, just put a 0 there. Please put a 0 there. Don't worry about the number. Alright. Then solve it. Then just take the 0 and just do 8 divided by 10.
You see intercepts, you should be thinking zeros. When you see intercepts, your brain should say 0. Something's going to be 0. Either the x or the y. When you know that, it takes half the problem. It takes the pressure off.
How do you know if you're solving for x or y?
That depends on where you put the 0. So,
You choose. You're in control.
right. You need to find both of them, so it doesn't matter which one you do
Wow.
first. It doesn't matter which one you do first. I could start solving for y, but if I'm solving for y, x needs to be 0.
But will it still come out as like the same answer?
Yeah,
Oh,
it doesn't matter
no.
which one you solve first, you'll get the same intercept either way.
I'm controlled.
But number 4 just be 56.
My hand here.
For which one?
Number 4.
Like for the x-intercept or the y-intercept?
X, which is 56.
Yes. Okay.
Times the rest of it.
So you did you have a question?
I think basically just said what I was.
Got it. Yeah, so the order doesn't matter. You'll still get the same things as long as you do the math right. We do need to make sure we do that part right. Alright, so let's go back and find our y-intercept. I'm going to do this again fully. So now we're looking for our y-intercept. X is now going to be 0. Which means this is going to become 0, this first term. So I'm really just left with 3y equals 24. So y is 8.
Oh, you say they just put the 0 on. Okay, this one actually kind of makes sense. If you have the power.
So these are the same thing we were just doing, the format is just different. This one you actually have to solve for both x and y, whereas the last one you were kind of given the y-intercept, you didn't need to find that part.
But on this one, it's basically the flip flop, right? So the 8x, you can just put the x on 3 and put the y on the 8. So that basically was out on the side. This 3 is 8 and the 8 is 1.
That worked for this one because of the numbers you got.
But
That one always worked out.
When you see intercepts, you're doing 2 problems for everyone. You have to think in terms of you're going to solve 2 different problems. You get to choose though if you get to do the x first or the y first. That's the exciting part. I mean, you are in control of which one you do first.
I don't know if it's anything exciting.
Oh, come on.
I mean, you could make it like a game, like which one first? Anyway.
You get to go first. X.
For the second one, so now I'm going to do the same process, but I'm going to make it go a little bit faster. So think we're still doing the same thing, but you're not going to see all that now. So if I'm finding my x-intercept, I know that I need to put 0 in for y. Think about that like, I put 0 in for y, it becomes 0, it disappears. So now I'm covering this up, I don't see it. Just put what's left, or x equals 8. So basically I'm skipping these first 2 steps and moving to this step. So x equals 2. Wow. Still think in your mind, I put 0 in for y, I solved, it disappeared, and now my x-intercept is 2. I just didn't write down that part. In this case, we can do the same thing for y, except if I put 0 in for x, it becomes 0, it disappears. When I put these two equal to each other, there's nothing to solve because there's no number in front of y. So y is just 8. We're gonna do 5
What's the
and
value
6.
of x on the y-intercept?
Yeah, that's what no, nothing is
So we're going to do 2 more, and we're going to do 5 and 6. But these will make a little bit more sense when we get into like slope graphing, writing them. But I just want to show you what these look like also. So first, I'm going to graph this so you see what that looks like. If you were writing, I'll come back to that. Ignore this for 1 second. Like when you're doing your own work, yeah. Khan Academy, stuff like that, yeah. Okay, so this is the line x equals -1. I don't know why I'm so... anyway. Where would this line cross the y-axis?
The x-axis?
Where would this line cross the y-axis?
Oh, I got you.
-1 or -2.
Wait, the y-axis
So
doesn't have
this
up
is
and
your
down?
y-axis.
None.
Oh,
Zero. Nada. Zero.
Okay. We have to be very careful. So if we put 0, that means it would cross right here. Does it cross right here?
No. Is it cross
that
anywhere?
So because it does not cross at 0, we can't say that it crosses at 0 for our y-intercept.
Okay, say nada.
We can say nada, nothing, none, doesn't apply, doesn't exist, any of those. We just can't put 0. But for our x-intercept, so this is our x-axis, we're going to cross the x-axis, -1. It's kind of like a trick question because it gives you that information already. You don't have to solve for it. So the x-intercept, and I'm going to draw that graph just so we have it as like, it was here. So our x-intercept would be at -1, but we would not have a y-intercept at all. No, none at all. Because if I put 0, 0, that means it goes through that point, and it doesn't.
When an x equals like 2 in that case, that means it could be, what's the value of x at negative y? If y is -5, what's the value of x? If x is 2. Right. If y is -5 or -3, here's the problem. X equals 2. These are all y values, right? They're all on the same line. I'm just trying to get you to see. X equals 2, just the way to see it. All these numbers of y are still, doesn't matter, right? You can put any number you want for y. That's why it's a line. You say you don't think x equals 2. What's y? Well, y is whatever. Y is any number. All numbers. Infinity. Right? So this, you think of it, x equals something, y equals something. It's going to be a line.
For 6, if this were the graph of y equals 5, yes. So what is our y-intercept? +5. What is our x-intercept? Nothing. It does not cross this at all. So the only time that would be, or you would have a value for that, is if it were like the x-axis. But then it would cross here and here and here and here and here, like everywhere. You'd have infinitely many solutions there, and you wouldn't get a problem like that. So our X-intercept would not be 9. Wow, that was really fun. And our Y-intercept would be at 5. I have not, but
You got it. You should.
I don't honestly have any control over that. I just teach what they tell me to teach. Right? Yeah. I want you guys to go back and do 3, 4, 7 through 10. And then the other 3 on this page that we did not get to. At 2, I'll show you the answers, so you don't have much time to work on those, but you do have the rest of that. When we go over them, I'll go over them quickly and then explain any assignments that you have before announcement. So for that first page, number 2, the handwriting up here is really small, so I'm just going to read them off. Just check yours. Number 2, the X-intercept was -1, the Y-intercept was 2. For 3, the X and Y-intercept were both 7. For 5, the X-intercept was -4, the Y-intercept was 2. Questions on those 3? I'm going to read through the answers to the other ones really quickly. If you did not get a chance to finish those, I do want you to finish them. That way you get some good practice in. Number 3, the X-intercept was 12, Y-intercept was -8. 4, the X-intercept was 56, Y-intercept was 8. 7, the X-intercept was -1, Y-intercept was -10. 8, the X-intercept was -3, Y-intercept was 7. 9, the X-intercept was -4, Y-intercept was -8. And 10, you could have put the decimal or the fraction for the X-intercept. So -25 over 4 or -6.25. And the Y-intercept was 5. Okay, really quickly, let me explain assignments. You have one Delta Math assignment on intercepts that is due by next class, so Tuesday. So it doesn't matter when you do it, but Tuesday. Bring any questions you have to class on Tuesday. You have 2 Khan Academy assignments. One is intercepts from a graph. The other is intercepts from an equation. Both of them, they're usually due on Friday, but we just did this today, so I'm giving you another day, couple days. So it's due by Monday night, but you could work on them before then and get them done as well. So those 2 Khan Academies, that one Delta Math, bring any questions you have on any of those to class on Tuesday. All right, any questions on those things?
If X is 0, is there a Y-intercept?